All right, good afternoon, everybody. Thanks for coming back. I'm delighted to introduce Ian Gorrie, who's going to be putting on a presentation here while we wrap up lunch and get back to our panels. Ian is the principal consultant of Locked Networks. He has been providing security consulting for 18 years, leading projects at all levels of engagement, including deeply technical implementations, risk management and strategy, improving security programs, and supporting policy. He began his career working for web startups and internet service providers. Ian is a chapter leader for the Seattle chapter of the Open Web Application Security Project, OWASP, of which we've already mentioned quite a few times. And he's also a former director of the Seattle chapter of the Information Systems Security Association. So please join me in welcoming Ian.
Hi, everybody. So my name's Ian. Welcome to Start With Security. So I'm here to introduce you to some of the free materials that are produced by OWASP, a nonprofit organization dedicated to addressing internet security and web application security, like the name. So before we go into how we should spend the time on building security and then building it into the development process, let's talk a little about why we have a need for this. So what's the problem we're addressing? Really what we're talking about is the anti-patterns of treating code hygiene and design mistakes like an optional feature request or a bolt-on effort after development is largely completed. That the rush to market is worth the risk of underachieving data protection measures, and that this creates a vacuum in the market opportunity for crime and mischief. Let's say, so the less effort required for the attacker to exploit, the lower the bar to entry. So what do I mean by an anti-pattern? It's a common pattern of behavior that those with the best of intentions can fall into that decreases or reduces project productivity. Typically, in application development, the fundamental prototype generally becomes the production environment, and the cost of correcting design and business logic problems becomes greater with time. Without attention, this leads to the behavior of piecemeal and ineffective efforts to correct this after the fact. This means that mistakes that are made are generally long-lived and, once the problem is realized, can make the cure appear more painful than the condition. It's far more cost-effective to plan and test for required functionality in the design and unit test stage instead of trying to make corrections down the line. So how do you do that, right? There are a lot of different methodologies, and everyone says they're an expert. So how do you pick the most efficient and easiest way to implement the strategy for bringing your efforts under the best practice tent from all the others? So I'm here to introduce you to one of the best ways, I think, using open materials which are free and accessible to all, created by a nonprofit organization of volunteers dedicated to this mission. So in an effort to simplify the difficult tasks ahead of most people, such as those here in this room, OWASP has produced a, actually it's a little head, OWASP, that's OWASP. They produced a lot of mature work product, which is available for free, and some of these things are the OWASP Top 10. Actually, I've screwed up my slides. So some of these are the OWASP Top 10, the OWASP Top 10 Privacy Risk, the OWASP Mobile Top 10, and the mapped and the actually, where am I here? I was going to talk about that. Yes, I will talk about that later. Where is my slides? I'm terrible. I'm sorry. So here we are. So these are the most common problems. Problems are interesting, but how do we prevent them from occurring in the first place? What's the proactive approach? And so that's the OWASP proactive controls. So first of all, the OWASP Top 10. We're probably familiar with many of these. These are the common problems found in web applications. So, well, these are them. So that's a whole talk by itself. And so these are the problems. So I just wanted to give an example of how SQL injection works, as it's one of the more common problems that occurs. So here we have an attacker at the end there, And they can send a web request to the web stack. So that gets forwarded to the data layer. And then the data layer returns as it's asked, the data that's been asked for by the malformed request, so it drops tables. And then that's delivered straight to the attacker. That's how SQL injection works. So how do the proactive controls work? So these are all the controls. We don't have enough time to talk about all of them, but I will gloss over them. The most important one is the first one, and that's verify early for security, and you do it often. So the theme here is you integrate unit tests and design considerations in your agile processes and sprints, and then you add tests for found problems in your code base so that they don't recur again. And so here's the other ones. So this is an example of parameterizing queries. This is not my notes. Just a moment, let me pull up my correct notes. I don't know why this isn't loading. Sorry, everybody. It's always something, isn't it? Oh, yeah, this makes more sense. I was wondering why my notes didn't fit. All right, so verify for security often. Actually, let's go back. So in many organizations, security testing is done outside the development testing loops following a scan then fix approach. The security team runs a scanning tool or conducts a pen test, triages the results, and then presents the development team with a list of vulnerabilities to be fixed. So that's an inefficient process and deals with things after the development cycle is already complete. More ideally, security testing needs to be done as an integral part of the developer engineering practice, so you need to integrate this and verify early and often, and you do this either through manual testing or more ideally through automated methods. Integrated testing and unit tests and design considerations can convert these tests into reusable proactive controls, and this has the opportunity to save considerable time as whole classes of problems can be eliminated from the code base and their reappearance prevented in the future. So all these other ones are important as well, and I'll just briefly go through them. So parameterized queries helps address SQL injection and is a major part of many security frameworks and can help prevent the theft of your production database and other data. Encoding attacks can help prevent a variety of attacks, especially injection. Validating inputs is, so any data which is directly entered or influenced by users should be treated as untrusted. An application should check that this data is both valid before using it in any way. So authentication and identity is a huge topic and it covers a lot of stuff. But so really just the process of verifying an individual or entity is who it claims to be and that the application sessions remain valid. Big topic. Authorization, a little different than that, is the process where requests to access a particular feature or resource should be granted or denied. It should be incorporated as a mandatory control check. It should deny access by default. And it should employ the principle of least privilege. And it should occur server side, not client side. You don't want to trust clients. So you should protect your data in transit and in rest using encryption and local access controls, especially on mobile. Logging and alerting, logs. Not only important for troubleshooting, but can also be employed to forward the cause of business analytics, intrusion detection, and forensics. Error and exception handling, this is not very exciting, but it can lead to problems if not addressed with sufficient care, such as data leakage. Frameworks and libraries leverage mature and hopefully well-tested existing efforts so that you don't have to develop solutions to complicated problems from scratch. So the proactive controls so verify early and often. I want to kind of dive a little deeper into this. there is a standard, OWASP has a standard testing base called the Application Security Verification Standards Project. And it provides a basis for testing web applications and technical security controls, and also provides developers with a list of requirements for secure development. And so that can be very helpful if you're looking for things to implement into your testing. As mentioned, utilization of frameworks and libraries, the advantage of employing good works that others that have created adds a lot of value and time savings in leveraging a mature tested code base for these functions. So if you're coding in, standard. So if you're coding in .NET and you want to prevent cross-site scripting in your application, you can call the anti-XSS library, which is totally available for you to use from MSDN. Or if you have a Java code base and you want to make your application more resilient to attack, you could utilize the security features in the Spring framework. So not only can you save time in not remaking the wheel and employing features of your chosen frameworks, but getting to know the frameworks that match your technology stack, you are utilizing and will dramatically reduce the difficulty to implement safer functionality. So this is why the art and craft is usually called a developer maturity program. It's improving developers to avoid classic mistakes, and also allows them the ability to write software free after you get moving and everyone understands what to do, free of typical problematic anti-patterns, yielding a more robust code base and capable development team. So I wanted to go through an example here of, say, a test that you might want to do, which might not be obvious, is so if you're doing an unsafe thing like writing to a local file system or accessing something that maybe should be a higher assurance activity, you might not want to just check to see if it's a valid user and a valid role, but you might also want to check the opposite. So to check to see if it's an invalid user or if it's an invalid role. And so here's a code example. So this is something that you could put in as a test. And so this tests if the user is valid with a valid role. This is a Spring example for Java. And then this tests if it's an invalid role. And this tests if it's an invalid user. So if any of those tests fail, it will be denied, and as opposed to just one succeeding, it will go ahead. So this all fits into maturity models. So this is another thing that I wanted to mention here at the end, just to kind of go over to kind of broaden the understanding of what's kind of involved. This is a high-level representation of the domains of the OWASP Assurance Maturity Model, SAM. I mention this because establishing the maturity of startups at exit in many other situations is becoming commonplace, and this is an entire talk in its own right. But you can see that each of these domains has its own maturity score, and when startups are coming to exit, and or sometimes in third-party compliance and other kind of pipeline security management or risk management features, they're starting to get into this, and they want to see people's results. So that's pretty much it. So these things here, the OWASP top 10, the top 10 privacy risks, mobile top 10. These are completely available for you to look at, to bring into your own programs. And so I have there's other examples here in the PDF. Should be on the website, or well, it should be available. So thanks.
I know we've ended a little early. Does anybody have any questions before we let Ian go?
How would you recommend someone go about actually bringing OWASP into their organization and evangelizing it if it's not there already?
Well, there's a lot of materials available. You can be self-paced. You can get formal training from people affiliated with OWASP. OWASP doesn't do training itself as a nonprofit, but there's a lot of people who are big fans of their body of work, and Or yeah, there's a lot of ways that you can do that, but a lot of it's all the materials being open. So it can serve as a reference, or it can serve as yeah. Well, I would say either a reference, or you can need professional help, or you can have it be a self-study. That's a good question. Vetting third-party libraries. Well, I would recommend looking at their mailing list archives, or maybe their list of bugs, or when it was last reviewed by. Yeah, I mean, a lot of open source projects do go through third-party review, and when that happens, it's usually, I mean, people usually do a good job of it, and they're usually proud of their work, so they post it usually. Did you have anything in mind? Okay.
Okay, thank you very much, Ian. So we have a few minutes before we resume the next panel at 1:30. We're going to show another video right before that, so there's a few minutes you have to yourself, and then we'll get rolling in a few. Thank you.